Many students are confusing to determine the page fault rate. So I am taking another example to determine the page fault rate using the page replacement algorithms. Okay, so this is the second example of the page replacement algorithms. So I will solve this question using these three methods, right? So consider the following page reference string 1234215621237 Determine the page faults rate using the following page replacement algorithms, assuming that there are 3 frames in the memory. Okay, so in the memory there are 3 frames. Remember, all frames are initially empty. So your first unique page will all cost 1 fault each, right? So LRU replacement, FIFO replacement, and optimal replacement. We will use these 3 algorithms to determine the page fault rate. Okay, let's start. So one will be page number 1 will fit into the frame number 1. Just a minute. Okay, so 1, this is the page fault, right? Then 2, so 2 will fit in the free frame because all the frames are free right now. So this is also page fault. 1, 2 and 3, this is also page fault. Now 4, so we need to replace the page. So this is LRU method. Remember, least recently used method. So the page that is not used for a longer period of the time will be replaced by 4. Okay, so page number 3 is recently used, 2 is also used, 1 is used, but it is a least recently used page. Okay, so 1 will replace by 4, so 4 will be here, 2 and 3, right? So this is also page fault. Now 2 is already there, so we don't need to replace the page. Now 1, so we need to replace a page now. So 2 is recently used, then 4 is also recently used, 3 is the least recently used. Okay, so we have to replace 3 by 1. So 1, 2 and 4. Okay, so this is page fault. Now 5, so we have to change the page, replace the page now. So 1 is recently used, 2 is recently used, and 4 is the least recently used. Okay, so 4 will be changed by 5. So 1, 2 and 5, this is also page fault. Now 6, so we have to replace the page now. So 5 is recently used, then 1 is recently used, but 2 is the least recently used, right? So 2 will be replaced by 6. Okay, now this is also page fault 2. So we have to replace the page again. So 6 is recently used, 1 is not recently used, so 1 will be replaced by 2. 2, 6 and 5. Now 1, so we have to replace the page. So we will replace 5 to 1 because 2 and 6 recently used, but 5 is the least recently used. Okay, so 5 will be replaced by 1, 6 and 2. Now 2 is already there, so we don't need to replace the page. So 2, 6 and 1. Now 3, so we have to replace the page. So which page will be replaced now? So see here, 2 is recently used. Okay, 1 is also recently used, but 6 is the least recently used, so 6 will replace by 3. So 2, 3 and 1, this is page fault. Okay, now 7, so which page is will be replaced now? So 3 is recently used, 2 is recently used, 1 is the least recently used. Okay, so 1 will be replaced by 7. So 7, 3 and 2, this is also page fault. Now 6, so which page will be replaced now? 2, right? So 2 is the least recently used page, so 2 will be replaced by 6, 3 and 7. This is also page fault, right? So number of the page fault is 1 2 3 4 5 6 7 8 9 10 11 12, 12, right? And total number of the page is 14, right? So page fault rate, how you will calculate page fault rate? So 12 by 14, 12 by 14 multiply by 100. Okay, so this is the calculation I will solve now. Divide by 14, it's 85.71%. 85.71%. Okay, so this is called page fault rate. Okay, 85.71%. This is page fault rate, right? So this is the LRU algorithm, least recently used algorithm. Now I will solve the same question using the FIFO page replacement algorithm. So this is the FIFO page replacement algorithm. Now the page will be replaced first in first out, yani the page that comes first will be replaced first. Okay, so 1 is entered to the memory, so this is page fault, right? Okay, 1 and 2, this is also page fault. 1 2 3, this is also page fault. Now 4, so we need to replace a page. So 1 comes first, so 1 will go out first, right? So 1 will replace by 4, so 4 2 3, this is also page fault. Now 2, so 2 is already there, so 3 2 and 4. Now 1, so which page will be replaced now? 2, because 2 is the first page that enters here, okay, after 1. So 2 will replace by 1, right? So 1 3 and 4, this is the page fault. 5, now we have to replace another page. 3 is the first one now, so 3 will replace by 5. So 5 1 and 4. Now 6, so which page will be replaced now? The page that enters first will replace first, so 4 will replace first now. So 6 1 and 5, this is also page fault. 2, so which page will replace now? 1. Okay, so 2 5 and 6. Now 1, so which page will replace now? 5, right? So 1 2 6, page fault. Now 2 is already there, so 1 2 6. Now 3, so we have to replace a page now. So 6 is the oldest one, so 6 will change now. So 3 2 and 1, this is also page fault. Now 7, so which page will be replaced now? 2, right? So 7 3 and 1, this is also page fault. So which page will replace now? 1 will replace by 6 6 7 and 3, this is also page fault. So number of the page fault here 2 4 6 8 10 12, same thing. Okay, 14, and you have to find the page fault rate. So 12 by 14 multiply by 100, so same result you find here, 85.71. so 85.71%. okay, so this is the page fault rate, right? This is FIFO, first in first out algorithm, right? So you have to replace the page that comes first. Okay, now optimal page replacement algorithm, so you will replace the page that will not be used for a longer period of the time. Okay, so that page should be replaced first, right? So 1 enters, this is page fault. 2 enters, this is page fault. Now 3 enters, this is also page fault. Now you have to replace the page. So which page will be replaced in optimal page replacement algorithm? The page that will not be used for a longer period of the time. For example, we have 1 2 3 page, right? 1 2 and 3. See here, so 2 will be used here, 1 will be used here, and 3 will be used here. Okay, so 3 is the page that will be used in the future, yani longest period of the time. 3 has longest period of the time. Okay, so 3 will replace after 1 and 2, right? So 3 will change here. So 4 2 and 1. Okay, page fault. Now 2 is already there, so we don't need to change the page. So 4 2 1, 1 is already there, so 4 2 1, right? Now 5, so which page will replace now? See here, 4 will be used, 4 is not here. Okay, 2 is here, and 1 is here, but 4 is not here in the page. Okay, so 4 will replace by 5, so 5 2 and 1, right? Then 6, so which page will be replaced now? So 2 and 1 is there, and 6 is here. Okay, so 6 is the has the, sorry, 6 also here, right? So 6 will be 5 2 and 1, sorry, there is no 6, 5, right? So 2 and 1, 5 is not there, right? So 5 will change by 6, so 6 2 and 1. Understand this point? Okay, now 2 is already there, so 6 2 and 1 is already there, 6 2 and 1, 2 is already there, 6 2 and 1. Now we have to replace the page. So 6 is there, okay, and but 2 and 1 is not there, so you can change 2 or you can change 1, right? So 6 3 and 1, I change 2, right? This is the page fault. Now 7, so 6 is there, but 3 and 1 is not there, so you can change 3 or 1 by 7. Okay, so 6 7 1, right? So this is also page fault. Now 6, so 6 is already there, so 6 7 and 1. Okay, so how many page fault in this question? 1 2 3 4 5 6 7 and 8. So number of the page fault is 8, right? Total number of the page are 14, right? So 8 divide by 14 and multiply by 100. Okay, so how much? Just a minute. 8 divide by 14 and multiply by 57.14. 57.14%. Okay, so which algorithm is the best algorithm? So the algorithm that has for page fault rate less, okay, less page fault rate, then that algorithm will be the best algorithm. So optimal page replacement algorithm is the best algorithm. Okay, okay, I hope you all understand these three methods, right? So thank you for watching.